Hi folks, we're going to take a look at page 575, number 9a. So here they want us to find the points where this function has a horizontal tangent. So in other words, that's like asking us for when the derivative of this function is equal to 0. Okay, so let's start by taking the derivative. So here I'm going to start off by using the chain rule. So I'm going to think of this as u squared. Derivative of u squared is equal to 2u, so 2 times x ln x. Okay, and then I'm going to find the derivative of u, the inside of the bracket, with respect to x, and here I'm going to have to use the product rule. All right, so here we've got the derivative of the first function, which is just 1, times the second function, so ln x, plus the first function times the derivative of the second function, which is just 1 over x. All right, and now I want to determine the horizontal, where it has a horizontal tangent, so I'm going to set the derivative equal to 0. Okay, so let's clean this up a little. So we have 2x ln x, and then in the bracket, it looks like we're left with ln x plus 1, okay, since these reduce. Okay, so I already have it in factored form here, so that's going to work out nicely. So what do we have? Well, 2 can never be equal to 0, but we can have x equal to 0, or ln x equal to 0, or ln x plus 1 equal to 0. Okay, so let's start with this first one here. So we know that x can be equal to 0, but remember that our original function has a logarithmic expression in it. So anytime that's the case, you need to check that any answer satisfies the original equation. And I see here that I cannot take ln of 0. It's only defined for values greater than 0, so I need to eliminate that answer. Okay, here I can either think intuitively, when is ln x equal to 0? Well, that just happens at x equals 1. ln 1 is equal to 0. Or if I take the natural exponential function base e of both sides, well, that's just going to give me x equals e to the 0 is 1. So either way, I get to the same answer. Now, the reason why I'm keeping this one is because I can take the logarithm of 1. Anything greater than 0 is valid. All right, so here we've got ln x can also be equal to -1. So again, if I take the exponential function base e, both sides, I end up with x is equal to e to the -1, or 1 over e. All right, so there's my second value. However, they're asking for the points where this has a horizontal tangent, so I just need to determine the y values. Okay, so here if I stick in x equals 1, I have 1 times ln 1, which is 0, so y is equal to 0. So one of my answers is going to be 1, 0. All right, and now let's take this and put it in the equation and solve for f at 1 over e. So f at 1 over e is equal to, what do we have? We have 1 over e, okay, times ln of 1 over e, okay, squared. So here I have 1 over e, and let's figure out what this is equal to. So this is like ln e to the -1. I actually probably should have left it in this form. And since the natural logarithm and the exponential function base e are inverses of each other, ln of e to the -1 is just -1. Okay, and of course when I square all this, that just becomes positive, so this just becomes 1 over e squared. Okay, so what are my two answers? Okay, so it has a horizontal tangent at the point 1, 0, and it also has a horizontal tangent at the point 1 over e and 1 over e squared. All right, so let's just do a quick recap here. Have to determine when a function has a horizontal tangent. That's equivalent to determining where the derivative is equal to 0. Okay, and when I'm solving any equation that involves logarithms, I need to make sure that any answer that's produced is actually a valid one based on the domain of the logarithmic expression. In this case here, it needed to be greater than 0, which is why I had to eliminate the answer x equals 0. All right, that's it for this one.